Spoiler alert, nuclear radiation is very dangerous. But I'm going to give you some reasons why you should be less afraid of it and how we do and should use it. First of all, what is nuclear radiation? Well, nuclear radiation is ionizing radiation that comes from the nuclei of atoms. Unless there is a huge amount of it, ionizing radiation is not very harmful to this table, the ceiling, the walls, my clothes. But it is very harmful to living cells.
Oh, man!
It can cause cells to mutate, become cancerous and even die. So for us as human beings in higher doses, it can cause serious burns, radiation sickness and death. To understand why ionizing radiation is so harmful to us, we need to look a little at the structure of living cells. Living cells are tiny, amazing little machines that have multiple functions. At the heart are some long, complicated molecular chains that form DNA. If something is ionizing, then it can cause atoms to lose or gain electrons and become charged. If a long molecular chain becomes ionized in places, then it will change shape or break. This change means the molecule carries different information and will perform a different function. This can ultimately mean that the cell will not work properly. It may die, may mutate, or may suddenly start reproducing in a cancerous way. None of that is any good. It's not just nuclear radiation that is ionizing. X-rays can be ionizing too, which is why hospitals take such care to avoid unnecessary exposure to their patients and staff. In certain circumstances, nuclei can also give off neutrons. Now these can be incredibly ionizing, and they're the only form of ionizing radiation that when absorbed can cause something else to become radioactive. Nuclear radiation is broken down into 3 types: alpha, beta and gamma. An alpha particle is made of 2 protons and 2 neutrons. It is the most ionizing of the 3. Next we have beta, which is a high energy electron. Now electrons don't exist in the nucleus, I hear you say. Well, no, they don't. But when a neutron suddenly decides it wants to become a proton, it also forms an electron, and that electron is ejected from the nucleus because it goes, hey, I don't want to be in the nucleus, I'm an electron. Beta radiation is very ionizing, but not quite as ionizing as alpha. Gamma radiation is an electromagnetic wave, and it is the least ionizing of the 3, but it is still dangerous. With alpha particles being the biggest, they are the least penetrating. They are easily stopped by a short distance in air, a piece of paper, or even the skin, and the outer layer of skin is dead. So as long as we're not too close to them, they don't really pose much of a threat to us at all. Beta particles are more penetrating. They can get through a few millimetres of aluminium or about a metre of air or the soft tissue of your body. But so long as the source is a good distance away from us, we are pretty safe. The real danger with alpha and beta is if we breathe in or ingest a source of alpha or beta radiation, then it starts emitting inside us, then that's not good news at all, not good. Gamma radiation is very penetrating and is only really stopped by thick lead or several metres of concrete. Even then, it may not all be stopped. It can travel considerable distances through the atmosphere without being absorbed. It's quite probable that cosmic gamma rays, are passing right through us right now. I should point out that gamma rays travel at the speed of light, beta particles nearly the speed of light, and alpha particles considerably slower. So, if ionizing radiation is so dangerous, why should we want anything to do with it? Well, for a start, it could save your life. You may well have a source of alpha radiation near you right now. Some types of smoke detectors have americium inside, which is an alpha emitter. The alpha particles ionize air between 2 charged plates connected to a battery, and a current flows. When smoke enters the detector, the smoke particles neutralize some of the air particles, and there's a detectable change in the current, triggering the alarm. Don't worry though, the americium is shielded, and even if the alpha particles could escape, they can only travel through a few centimetres of air, so you are pretty safe. Well, no, you are safe, and you would only be at risk if you decided to eat your smoke detector. Really? There are several uses of ionizing radiation in hospitals. One of them is to kill cancerous cells. That's called radiotherapy, and after surgery it is probably the most successful treatment of cancer. We can also use nuclear radiation to diagnose other problems inside the body. By injecting or ingesting a source of nuclear radiation, we can track what happens to it inside and see what happens to our digestive tract or our bloodstream. When we use a source of nuclear radiation like this, it's called a radioactive tracer. It can help detect internal bleeding and several other health problems. The radiation given off is detected outside the body and is used to produce an image to see what's happening. Of course, an alpha source would be no good for this because it can't penetrate the body. Other uses of nuclear radiation are to detect the thickness of materials during the manufacturing process, such as paper or maybe aluminium foil. Ionizing radiation can be used to irradiate seeds or even food for us to eat. It kills the bacteria on the surface, ensuring that it will store or keep for longer. Irradiation sounds like a scary word, but I should point out to you that just because we bombard something with ionizing radiation, it doesn't become radioactive or harmful itself. It's a bit like me shining a torch on an apple. And when I shine the light on the apple, then suddenly turn the torch off, the apple itself hasn't caught the light and suddenly starts giving off light itself. That would be daft. Of course, I can't finish this video on nuclear radiation without talking about nuclear power. Most of us agree that we need to reduce greenhouse gases and atmospheric pollution. That means we have to stop putting crap into the atmosphere. One of the ways of doing that is to use more wind and solar, but they're unreliable. So for times when they're not working, we need to use gas to produce electricity. We use gas because it can be turned on and off very quickly, and it is reliable. So using wind, solar and gas means we're still putting stuff up in the atmosphere. Nuclear power does not do that. Once the power plant's constructed, it puts nothing into the atmosphere except for water vapour. It takes up much less land, and even the stuff it does put in the atmosphere while it's being constructed is much less than the equivalent number of solar panels and wind turbines. There are two problems with modern nuclear fission power stations though. The first is the radioactive waste, and while it will remain radioactive for thousands of years, and there's nothing we can do about that, there's not very much of it, and we can store it safely. The same cannot be said for pollutants from other methods of power generation. The second problem is a big one. It's people's fear, their misconceptions, and their reluctance to have a nuclear power plant on their doorstep. Nobody can deny that Chernobyl was a terrible disaster, and for those of us who were alive then, it still sends shivers down the spine of most of us. A lot has changed since then, and the risk of something similar happening again is much, much less than the inevitable climate disaster that we're walking into. What's more, the premature deaths attributed to air pollution are over 7 million a year according to the World Health Organization, and that really is scary. So whether we are fighting cancer or climate change, nuclear radiation really is our friend. If you found this video useful or interesting, then like or subscribe, and you may well watch this one.